Okay, this is the lecture for the set cover problem. So go to the starters folder and click on set cover. Okay, so hopefully you remember this. We're trying to locate ambulances in Stillwater. We have these 5 different sites that we're considering. And we want to make sure that each one of these 6 different landmarks is covered. And by that, we mean that we should locate an ambulance within an 8-minute drive of each of these locations so that we can respond to emergencies quickly. And in this initial model, we're just going to try to minimize how many ambulances we actually have to place. So, okay. So we have as input this kind of travel time going from, let's say, site 1 to the airport. Let's say it takes 2 minutes. So this site 1 could cover the airport, and it could also cover Boomer and the movies and the library, but it's too far to cover Hideaway or Couch. Okay. So we're supposed to figure out which of these 5 sites we should pick. So I've done the hard work for you, and I've typed up this travel time matrix as a Python dictionary. So let's go ahead and run that one. And then just to test it, let's figure out time in minutes from site 3 to Edmund Low. So from site 3 to Edmund Low should be 5 minutes. Let's check that. Okay. So it'll be convenient in what we're about to write to have something with a list with a set of sites. So that is going to be, actually, it'll be helpful just to use this as, define this as a set. Okay, so this is the set of I for ij in these of this travel time dictionary. If I wanted to, I could also just say list range 1 to 6. It'll work, but I'm trying to use as much as possible this dictionary that we already have. And also it's convenient if I'm talking about those 6 landmarks. Now I can just say J. So the sites are sites and landmarks are. So let's just see if that works. Yes, okay. You may wonder why I used set here, so these curly braces, instead of using the list, the square bracket. And the reason is that these i's are duplicated. So this I appears paired with multiple different j's, and so I don't want duplicate copies of this I. So if I were to use square brackets here, I'll show you what it would look like. We'd have the 1's copied over and over, the 2's copied over and over. So just to keep one of each of those, I use set. Okay. So then let's look at each one of these landmarks and see which sites are close to it. And we're going to store that in here, close sites. So that's going to map each landmark J to the list of close sites. And so right now we'll just map it to an empty list, and then we'll write a little bit of code to figure out which ones are close. So for example, if you're looking at the airport and you want to know what are all of the sites that are close to it, it's going to be site 1, site 2, site 5. The 3 and 4 are too far. So we'll do that for each one of these landmarks. So for every J in landmarks, we'll say And I guess we'll also loop over the sites. So for every for I in sites, if travel time in minutes going from I to J is at most 8 minutes, then we'll say that they're close. And then in that case, we will append to this. So for landmark J, we're going to say that site I is close. And I guess if we wanted to, we could end here. Okay. So the airport we said was close to sites 1, 2, and 5. Okay. So that seems to be working. All right, so now we can define our Gurobi model. So again, I'll call it N. And then I'll define a binary variable for each one of these sites. So for every site, we will define variable of type. Okay. So our objective is to minimize the number of ambulances that we place. So over here, I'll have grb.minimize. And over here, I essentially want to add or sum the x variables. So I could write that that's maybe the clearest way. But another way to do this is just to do okay. So we've set our objective. Now let's set our constraints. The constraint for each landmark. And that constraint says among the close sites, pick at least one of them. I would do something like this. So I sum all of the xi's for I in close sites to J. You'll see that I have a constraint for each one of those 6 landmarks. Oh, it's pretty easy. Just 5 binary variables. We have 6 constraints, one for each of those landmarks. Okay, so our chosen sites are I for I in sites if that x variable equals 1, but we check that by just comparing it against 0.5. Okay, so it tells us to pick sites 2 and 3. And maybe we should just double check, confirm that that is feasible. If we pick 2 and 3, the airport will be covered. Boomer Lake, you could say, would be covered twice. Hideaway is covered twice. Couch Park is covered. Movies are covered. And Edmund Lowe is covered. Okay. But you'll see that, at least for the movies, the closest ambulance of 2 and 3 is 8 minutes away. So we are ensuring that the worst case response time is at most 8 minutes, but we're actually right at it. And so maybe you would ask the question, could we do better? Could we reduce that worst case runtime? So that's what we'll do next.